All right, guys, before we get started, are there any questions over the previous assignments? All right. Yesterday, we were working on 7.42, simplifying these rational expressions. We got most of the way through problem number 12, but we did not finish it. So, when we talked about this yesterday, we realized the expression we need to multiply the top and bottom of the fraction by to get all the fractions on top and bottom of this expression to simplify out was x minus 3 times x plus 5. Now we multiplied with the fraction on top. The x minus 3 times x plus 5 would be multiplied by the 3, giving us 3 times x minus 3 times x plus 5 on top over x plus 5. Now we did the same thing with the denominator, telling us that this first expression is going to be 2 times x minus 3 times x plus 5 over x minus 3 plus x minus 3 times x minus 5, or x minus 3 times x plus 5 over x plus 5, because we're multiplying that by the 1. So we got to this point here, or almost, I think, to the next step. Because at this point here, we're seeing what's in common on top and bottom. All right, guys, focus in. And on top, the x plus 5 and x plus 5. The first fraction on bottom, the x minus 3 and x minus 3. And in our last fraction, the x plus 5 and x plus 5. So we're multiplying by this expression so that our fraction on top, I'm going to write it out here to the side so we can see it in one frame, ends up being just 3 times x minus 3, because that's all that's left on top. On bottom, the first fraction, we still have the 2 and x plus 5 plus x minus 3. So the two fractions on bottom simplified to these two expressions here. Now, when we look at this here, the denominator, we do have two expressions that are going to be added together. So we do have like terms that do need to be simplified. So the first thing we can do is distribute this 2. 2 times x is going to give us 2x. 2 times 5 is going to give us positive 10. Now the x minus 3 expression, since there's not a number in front of it besides positive 1 and besides that plus, tells us that it's still going to be x minus 3. Because we do see that we do have the like terms 2x and x, 10 and 3, that we'll need to combine. Now we can factor the numerator, we can multiply through by 3, but are there going to be any terms that we need to combine with it? Well, no, it's already one expression, it's already in factored form, yes? So we could multiply it out and say 3x minus 9, but if there's going to be something in common on top and bottom, we need it to be in factored form, which means we would have to factor out the greatest common factor of 3, which is going to be what? 3 times x minus 3. So since it's the only term on top, unlike the denominator, we had 2 sets of parentheses. We had that addition. We had that combining like terms. All right, guys. Since we do have that combining like terms on bottom, we have to multiply it out so that we can combine the like terms. On top, because there are no like terms, there's nothing to combine, nothing to simplify. There's no reason to multiply the 3 out because we're going to have to factor it right back out. On bottom, 2x plus x is 3x. 10 minus 3 is plus 7. So we get 3 times x minus 3 over 3x plus 7. Questions on how we got to this here? Now again, very tempting to want to go 3 in front over 3 on bottom, cancel those out. But we cannot simplify those out because the denominator, that 3x, and the 7 are being added together. They are one expression. So we can't just cross out that 3 on top with the 3x on bottom. If we were able to factor a 3 out of both terms, then yes, we have product on top, product on bottom. That simplifies. That addition and subtraction really kind of messes things up. So this is actually as far as it goes. Questions on these here? One over a minus 3 over a over 2, 3 over a minus 2, all over 2 over a plus 5 over a minus 2. Now, the first main goal with simplifying these rational expressions is to get the fractions on top and bottom to simplify down. Because if I don't have any fractions on top and bottom, we reduce it really just to combining like terms. We can simplify as needed. Now, one thing I didn't emphasize a lot yesterday, because it would have made a big difference either way, but before we start finding what we need to multiply everything by, we need to make sure that we factor all the denominators completely. And the reasoning for that is if there's an extra factor or something that's hidden inside the factored form, and we don't factor it, we're adding that extra factor in. We'll still get to the same answer, but whatever extra factors we add have to be pulled back out. And up to this point, most of the factoring that you've had before Algebra 2 was we had an extra factor of 2, we had an extra factor of 6, a number, and luckily, calculators will remove that number for us. We don't have to do it. We don't have to do any of the calculations. It turns out that we got negative 150 over 90. The calculator is going to tell us, yeah, that simplifies to negative 5/3, which is fine. However, if I have an extra factor of a minus 2 on top and bottom, the calculator won't do that for us. We have to factor that back out. So if we can make sure that we don't add any factors in that we don't need, we don't have to take any extras out. Makes it a little bit nicer. So we're looking at this here. We have 4 denominators we're looking at. The top 2 are an a and a minus 2. Well, the a is factored because it's by itself, nothing we can do to it. A minus 2, no greatest common factor, degree is 1, it is simplified. Which actually means that the 2 on bottom are also simplified as well. That's also, I mean, because all the ones we dealt with yesterday were all factored. There's nothing we can do to it. So now we need to see what do we need to multiply everything by to get those denominators to simplify on top and bottom. A. Anything else? And a minus 2. And we're going to multiply it on top and bottom. So the first thing we're going to do is multiply that a times a minus 2 with our 1 on top. Well, a times 1 is just a times a minus 2 over a. Because I could really write 1 times a minus 2, but it's really understood to just be a times a minus 2. We'll do the same thing with our 3. So we'll have 3 times a minus 2 all over a minus 2. Questions with how we multiplied across the numerator? Now we're going to do the same thing with the denominator. Our a times a minus 2 is going to multiply with the numerator of our first fraction, which is 2. So 2 times a minus 2 all over a plus. We're going to do the same thing with our second numerator. We're going to multiply the 5 by a times a minus 2, which is 5 times a minus 2. Questions on this here? We good with this here? Let's see what simplifies. Well, our a minus 2 over a minus 2, a minus 2 over a minus 2, and we can cancel them out because on top the 5a and 3 are being multiplied by the a minus 2. They're not being added, so we can cancel there. For the same reasoning, our a over a can cancel because the a on top is being multiplied by that a minus 2. They're not being added. Addition subtraction is not there to prevent us from simplifying. Same thing is true on bottom. The a over a simplifies. So the numerator, the top of this fraction, what I'm left with is a minus 2 minus 3a. And on bottom we have the 2 and a minus 2 plus 5a. Questions on this here? Now, again, it's really tempting to just want to go a minus 2 gone. And the reason we can't is that a minus 2 on top is being subtracted with 3a. We have a subtraction there. They're stuck together. Same thing with the denominator. 1 is being multiplied by 2, which really doesn't matter. But the plus 5a is the issue why we can't just cross it out. At this point here, I would drop the parentheses on top. Because there is no number, there is no written sign for the a minus 2, it's just going to be a minus 2. The positive 3a is going to become negative, we just get minus 3a. On bottom, we're going to have to distribute this too. 2 times a is 2a. 2 times negative 2 is negative 4. And then we're just going to add 5a, plus 5a. A minus 3a. 1 minus 3. Negative 2a. Negative 2a minus 2. Yes? Yes. Yes, because on bottom our 2a and 5a would add together. 2a plus 5a is 7a. Giving us 7a minus 4 on bottom and negative 2a minus 2 on top. Now at this point here, we just need to make sure nothing simplifies, nothing reduces. So we have to check the top and bottom, the numerator and denominator, and make sure there are no greatest common factors or ways to simplify. On top, negative 2a and negative 2 have a greatest common factor of 2. Because we can take the negative out, we can leave it in. If I factor out negative 2, because they're both negative, the negative 2a is going to become positive 1a. As the negative 2 factors out completely, leaving us with our a term. Now the second negative 2, we are taking the negative out, so it's going to become positive. And 2 divided by 2 is 7a minus 4. No greatest common factor between them. So we have negative 2 times a plus 1 over 7a minus 4. Even though there's nothing in common, we still want to factor just to make sure there's nothing in common. Now, yes, we could have just factored out the 2. And if we did, we would have gotten this here. They are the same thing. One, I factored out the negative 2. The other, I just factored out the 2. Questions on this here? All right. We're going to do this one and one more, and then we will be done with 7.42. So the first thing, or the main thing we want to do, is get rid of the fractions in the numerator and denominator of this fraction. Am I going to look at the x or 4 on top or the x or 3 on bottom for figuring out what we need to multiply it by? Because that x minus 4x plus 3, are they a part of a fraction? I mean, the whole fraction, but they aren't themselves a fraction. So they're not causing an issue, because if it had just been this was gone, x minus 4 over x plus 3, that's fine. We don't have a fraction inside the fraction. The issue is with the 9 over 2x plus 3 and the 5 over 2x plus 3. That is what we need to simplify. Now, 2x plus 3 is fact. Degree is 1. 2 and 3 don't have a common factor, so we're good there. And most likely, what we need to multiply everything by is 2x plus 3. And we're going to start with this x over here. So we're going to have x times 2x plus 3 minus, we're going to do the same thing with our negative 4. So we'd have negative 4 times 2x minus 3, or plus 3. And then we're also going to do it to the 9 plus 9 times 2x plus 3 over 2x plus 3. Well, luckily, those 2x plus 3s are going to cancel. We're going to do the same thing on bottom. We're going to have x times 2x plus 3. Then we're going to do it our positive 3, so plus 3 times 2x plus 3 plus, not plus, that's going to be a minus. Keep track of my signs. 5 times 2x plus 3 over 2x plus 3. Just like with the fraction on the numerator, the 2x plus 3 and the 2x plus 3 will cancel. Now, one thing that is tempting with this problem, especially looking at these here, we see 2x plus 3 is in common with the top two terms, bottom two terms. We've talked about factoring by grouping to factor it out. However, there's not two terms on top. How many terms do we actually have on top? We have 3, because we have the x times 2x plus 3. We have the 4 times 2x plus 3. And then, even though it's kind of off screen, we also have the 9, because I have 3 terms. But after that's simplified, this third term is still just 9. All 3 terms don't have it. If they did, we could factor it out. It actually works quite nice. But here we can't, and it does look like we're going to have to combine like terms. So, you know what, before I start multiplying, I'm going to rewrite it. Because what we have once everything simplifies, or supposed to fraction simplify, because not everything is simplified, we have these three terms. So if that 9 had 2x plus 3, we could factor it out. It would work a lot nicer. On bottom, probably don't need that much, but I would say there's probably going to be some like terms with multiplying this out. So on top, the first thing we have to do is distribute the x. X times 2x is going to be 2x squared. X times 3 is plus 3x. Negative 4 times 2x is negative 8x. Negative 4 times 3, negative 12, and then we have our plus 9. On bottom, x times 2x is 2x squared. X times 3 is plus 3x. Positive 3 times 2x is plus 6x. 3 times 3 is plus 9, minus 5. So the first thing we did was just distribute those numbers, simplify those parentheses first. Combine like terms. 2x squared on top has no like terms. It's only x squared term. 3x minus 5x, not 5x, 3x minus 8x is negative 5x. Kind of already said it as I was trying to work it out. And lastly, negative 12 plus 9, negative 3. On bottom, we do have the 2x squared. 3x plus 6x, 3 plus 6 is plus 9x. 9 minus 5 is plus 4. Questions on this so far? We're good. We're still caught up. So this is the final answer as long as the numerator and denominator, the top and bottom, do not factor. I have a feeling they're going to factor. If we look at the numerator, 2x squared minus 5x minus 3, since there is no greatest common factor between 2, 5, and 3, 2 sets of parentheses with 3 spaces. Since the third term is negative, our signs are opposite, positive and negative. Now the factors of the first term, 2x squared, we will have x and x. I'm just going to stick the 2 with the first x, because we'll check it and make sure. I'm going to put it there first. Factors of 3 are 1 and 3. Do we want to put the 3 with the plus or with the minus? Doesn't matter. Which one do you want to put it first? Minus? And let's check this here. 2x times negative 3 would be negative 6x. 1 times x is plus x. Negative 6x plus x, negative 6 plus 1 is indeed negative 5. So that is the middle term that we wanted. Now our denominator, 2x squared plus 9x plus 4. No greatest common factor between 2, 9, and 4. But since the third term is positive, the signs are the same and match the sign of the middle term, which is also plus, telling us we have plus and plus. Factors of the first term, well, the x squared would be x and x. Factors of 2 are 2 and 1, so we get 2x and x. Now we need to figure out the factors of 4. 1 and 4 and 2 and 2. I would indeed go with 1 and 4. Because if we have 1 and 4, I can put the 1 with the 2x, giving us 2x plus 1 on top and bottom. So we do have a likelihood of something simplifies. And we can check and make sure. 2x times 4, 2 times 4, 8x. 1 times x is going to be plus x. And 8x plus x does give us the middle term of 9x. Which also means, what? It factors, both of them factors, and we also have what on top and bottom? 2x plus 1 on top and. So those factor out, leaving us with x minus 3 over x plus 4. Those are as simplified as it gets, so it actually reduces x minus 3 over x plus 4. Questions on this here? We ready for the last one? One over 2x minus 5 minus 7 over 8x minus 20 all over x minus or 2x over 2x minus 5. Now our first initial thought, and there's nothing wrong with it, would be to go, we're going to multiply this by 2x minus 5 on top and bottom. We're only going to use it once because the two places it shows up, it only shows up. And then we'd also multiply by what? 8x minus 20, because it does show up in one of the denominators once, so we're going to use it once. Eight x minus 20. Is there a greatest common factor between those two terms? Yes. What number goes into both 8 and 20? 4? 4 does divide into both, yes? So if I factor that 4 out of 8x, we're left with 2x. Minus, if I factor that 4 out of 20, we have 5. So, really, we weren't multiplying. If we'd have done that first step by 8x minus 20, that's really just 4 times 2x minus 5. So if we'd have done that step, it would still worked. We'd still got an answer, but we multiplied by 2 factors of 2x minus 5, and we only needed 1. That's why I was saying earlier, and we'll put this in here, we need to make sure we factor. Because that extra factor 2x minus 5 is going to make what we have to factor at the end a lot bigger than it actually needs to be. So instead of multiplying by that big expression, we still need to multiply by 2x minus 5, because that is going to be needed no matter what. What is the other piece that we need? 4. So we multiply this on top. 4 times 2x minus 5 times 1. It is 4 times 2x minus 5 over 2x minus 5. Minus our 4 times 2x minus 5 times our 7. We could do 7 times 4 times 2x minus 5. If you want to write it out as 28, because our 4 times 7 is indeed 28. That works too. Do the same thing on bottom. Our 4 times x is 4x times 2x minus 5 over 2x minus 5. in the denominator, that 2x minus 5 and 2x minus 5 will cancel. On top, 2x minus 5, 2x minus 5, cancel. And in the last fraction, the 2x minus 5, 2x minus 5 cancel. Also the 4 and 4. So it'd be 4 minus 7 over 4x. Even if we'd written it as 28, 28 divided by 4 is still 7. It still reduces. 4 minus 7 is what? Over 4x. Single term on top and bottom, so we can't factor it. 3 and 4 do not have anything in common. So that's it there. At least it didn't reduce to 1. Sometimes the longer problems that take half a page that reduce to just 1 are sometimes more frustrating than if you got something complicated. But that is, yeah.